Hi, this is Matt here at Jorgensen Machine Works. Got a video for you today showing some of the new iron that is coming into the shop, new machining iron, and so I thought I would. I'm finally ready to show what we've got coming in here. And those of you who follow my Instagram over the last several months have probably seen pictures of it as it was getting moved, and same with my Facebook page. And it's now stood up. This has been a project that's been going on since basically the first of the year, and it probably won't be finished until close to Thanksgiving, just for time to work on it and stuff. But we're going to turn the camera around and take a look at it. And it is right over here. There it is. This is a Wotan Rapid 1 CNC Horizontal boring mill. This unit here came as a project. It does, the CNC control does not work, and in fact it was not with it. It was, long story short, it was the CNC control got damaged due to a leaky roof. The guy who had it took his money from the insurance company and ran with it. And now that he's retiring, he had to get this thing out of his building in order to turn it back over to his landlord, and was basically looking for somebody to get it out of there. And I obliged him. This unit here, I'm a little short on details, but just for reference, that table is about 5 foot wide. The top of that spindle is above my head, and I'm 6'2" where it sits currently, and it still has another 2 foot of height. This unit is extremely heavy. The truck and trailer with the mill was over 75,000 pounds, so there's at least 40,000 pounds of boring mill here. The column was everything that our 18,000 pound forklift would pick up, and that's after we stacked extra counterweight on the back. This unit has a rotary B-axis, so the table right here rotates 360 degrees. 6 kilowatt servo motors. They're Indramat 150 volt DC servo motors. It has a 60 kilowatt, that's 60 kilowatts, 400 volts DC spindle motor with hydraulic tool changer, 3-speed gearbox. The unit has lubricators everywhere. There's a lubricating pump there for the spindle extension. There's another lubricating pump that mounts on the other side of the column that was removed for setting the column up so it wouldn't get smashed, that oiled the slideways. And there's another lubricating pump that's on the bed of the machine as well. There are telescoping slideway covers for here and here. The spindle motor this is, horizontal boring mills are a little different for those of you who aren't familiar with it. This right here is not your y-axis. This is Z, because Z is parallel with the spindle center line. And then, of course, the spindle has approximately 2 to 3 feet of extension out the sleeve. So this entire unit rotates. This will extend out close to 3 foot, like typical boring mill. That would be considered your W-axis. X-axis is left and right in the table. The table has no movement in this plane, only left to right for an X-axis. And your Y-axis is the head up and down. These are the buttons for the hydraulic tool change, power tool change. This is the electrical cabinet that contains the drives. Being a German machine, this machine was originally intended to run on 380 volts. There are a series of buck boost transformers on top that buck the voltage, 480 voltage, down to 380. The T-slotted table has trays on each end to catch coolant with chip screens. These then drain into the middle of the table, down, and coolant then exits out the end through that hose into a reservoir of some sort if you're choosing. You can see we got plates with blocks under it. The floor here is not at all level. This building was intended as a mechanic's shop, and because of it, the floors are sloped heavily to the drains. The day I set the bases up, I got them to within 1,000th per foot of level. My goal is, once the unit is wired and retrofitted and working, I will have a machine tool company come out and do a proper electronic leveling on it. But this'll do for now. At least nothing will bind that way when I go to start moving things. This is an aerostatic weigh machine. So if you can imagine, this column right here is at least 20,000 pounds, because our 18,000 pound forklift needed about 3,000 pounds of counterweight on the tail end in order to keep it down. And that actually rides on a cushion of air. So the bottom side of the slideways are coated with plastic. They have little tiny pockets in them. Oil is injected into those pockets, and then a continuous stream of air is injected whenever the machine is powered on. So this machine is basically one giant air leak. Every slideway, the vertical ways for the Y, the bed ways for the Z, and the bed ways for the X-axis here are all aerostatic, continuous flow of air. In practice, there is no metal-on-metal contact in this machine, so it will have virtually no wear from normal use. This machine dates to the early 80s, as best I can tell from the information I have. It was retrofitted once already to a Dynapath Delta 40 control. I will be retrofitting it again. I'm going to be using LinuxCNC. I am leaving the old Allen Bradley controls for the servo motors and the Indramat servo motors. I don't really have any compelling reason at this point to change over to new servo motors, especially when you have servo motors of this size. It would be quite expensive to do so at this time, and at this point, assuming all the servo motors work, I'm just going to go ahead and leave them for now and get it working. Anyone wondering what them two spots are up there? So this machine, being rough cast, actually had a nice coat of Bondo on it to make it smooth, and then the paint. And those are marks from the payloader we used when we took it down. The rigger's boom that was on the payloader, the back of it would bump into the column as it was hanging by straps, and it knocked out the Bondo there. It's cosmetic damage. I'll get it fixed and painted at some point, but for now it really doesn't hurt anything. This machine here also came with about 4 pallet loads of ISO 50 tooling. This spindle is an ISO 50 spindle, which from what I gather is the same as NMTB 50. The only difference being it has a metric thread instead of American. It's currently set up to use a threaded drawbar, not a pull stud. And I will probably leave it that way since it's going to be manual tool change anyway. A threaded drawbar is by far stronger than a pull stud, especially when you're dealing with a machine that can sink 40 some odd horsepower into a part at 400 RPM or less. I believe the lowest speed this machine is rated for in first gear is like 15 or 20 RPM. So if you imagine 40 horsepower being sunk into 20 RPM, the torque is just ridiculous. E-stop button. The machine, the servo motors just have tack outputs for the servo amps, and for position feedback, the entire machine uses Heidenhain glass scales. We will be keeping the glass scales. I'm not going to put rotary encoders on the servo motors. In my opinion, the glass scales, since they're already there, are a better way to go because of the fact that the glass scales measure the actual movement of your part or your tool, not the movement of the servo motor. Therefore, it's by nature got backlash elimination already figured into the process. Over there, you'll see the aerostatic and the hydrostatic. The aerostatic is basically an air filter dryer, refrigerated dryer with a filter regulator assembly built into it that'll be operated by the control cabinet. And then the hydrostatic looks to be about a 3 or 5 horse electric motor driving a couple of hydraulic pumps that pump oil to the spindle for the spindle bearing and for lubrication of the spindle in gearbox assembly. This machine uses hydrostatic spindle bearings. There is no rolling element in the bearings. They run on high pressure oil. So once again, virtually no wear if everything is operating as it should be. There are other pieces not shown here. The control, this large column here is going to get bolted to the floor somewhere convenient. It has an articulated arm that hangs on it for the control panel. That way you can have the control panel back here or out in front of the machine or even over by the table for working for jogging in the axes and stuff like that. We're primarily going to use this thing as a very large, very fancy manual boring mill. I've had a couple folks ask me, since I'm a repair shop, why I would go CNC. Well, first off, I couldn't beat the price of free. You know, obviously it wasn't totally free. I mean, there's obviously some significant cost in moving it, but not having to pay for the machine when you get this kind of iron in this kind of condition is quite compelling. Plus, even repair shops, there are some things we do that just simply will be faster with CNC. What I will end up probably running this thing in is a sort of conversational type mode with LinuxCNC. I will probably write some canned cycles for like bolt hole circle and stuff like that. Obviously, this will come into play instead of, for instance, axle housings. When we need to bore out axle housings that are damaged. Instead of having to make pass after pass after pass after pass with a boring head, we now chuck up a 2-inch end mill, or say an inch end mill, you know, depending on the size of the hole. We chuck in an end mill, we run the spindle out to just as far as we need to reach into the housing. Then we put a hammer indicator in, find center of the bore as best we can, same way as we do with a manual boring mill now, and then pull up a canned cycle for a circle mill with an end mill. All we have to do now is put in the diameter of the circle we need to get past the damage, the size of the tool, and the depth of cut from our home position. Cycle start. And what was 2 hours of going in and pass after pass after pass after pass with a boring head now becomes a few minutes letting the computer bore the hole out, double check our size, and we're off to the next thing. Same way with bolt hole circles. If we need to rebore a bolt hole circle and say an engine bell housing, find home, program your bolt hole circle, and let the machine do the heavy lifting of figuring out X and Y and drilling cycles instead of having to do it manually. Maybe not exactly the kind of work this machine was intended for, but it's going to work for us. So we will keep you posted as this thing gets closer to working. Like I said, I hope to be able to have it under power and at least moving by Thanksgiving. We'll see how that happens. But there's approximately 500 wires or so that I have to get rewired. I've got over 50 photos of different junction boxes that I had to unwire and tag all the wiring. Thankfully, the wiring was tagged from when the machine was originally put together, but I had to record those tag positions. So there's a lot of rewiring to do. And you know, we're pretty busy with work right now, so this is kind of taking, you know, the non-paying jobs always take the back seat. So but there it is. So yeah, this ought to be a very interesting machine to see going here in the coming months. So stay tuned. Have a great day. Thanks for watching. And go go ahead and subscribe if you want to see more of these videos as they come out.